Okay, now we just got done with vertical stretches. We know that when we multiply the outside of a function by a constant, it stretches that function vertically by that constant. Now what we want to do is now do an inside change where we multiply x by a constant and see what happens. It should be some sort of horizontal change. And I think if we're really fixated on what happened vertically, when I plug in my 2 for k, I'm thinking that's going to make the graph stretch by a factor of 2. Now I'm going to turn it on, click. Oh boy, that graph did not get stretched by a factor of 2. It got compressed by a factor of 1/2. In other words, the original graph had width 20. My new graph had width 10. Now, how to explain that? I think the best way to do this in terms of pre-calculus is that my new graph has exactly the same peaks and valleys and troughs, I guess. The heights of the mountains are the same, the depths of the troughs are the same, but it gets to them twice as fast. This graph goes up and down twice as fast. So instead of taking 20 units of time to do the whole graph, it only takes 10 units of time to do the whole graph. Now, the thing about it is the graph goes up and down twice as fast. That means it got compressed by a factor of 1/2. If I now go put a 3 in there instead, you can see that this new width is actually 1/3 of the original one. So putting a number up here into k bigger than 1, like 2 or 3, compresses the graph by exactly that factor because the graph goes up and down exactly that much faster. So put a 2 there, it goes up and down twice as fast, it gets compressed by a factor of 1/2. Put a 3 in there, it goes up and down 3 times faster, and the whole graph gets compressed by a factor of 3. What happens now if we put a number that's smaller than 1 in there, like a 1/2? Let's put a 1/2 in there. And I can't even see the whole graph right now. Let's zoom out a little bit so we can see the whole graph. And there you go. When I put a 1/2 in for k, the graph did not get compressed by a factor of 1/2. In fact, you can see that the new graph, the blue one, is exactly twice as long as the original. Why? What? Right? Why is that? Because we made that new graph go up and down twice, a half as fast as the original. It's got the same peaks and valleys. It's got 2 peaks, 2 valleys, but it takes twice the amount of time to actually get to them. Well, if you take twice the amount of time to get to them, you've stretched the graph out to 40 instead of out to 20. So what happens is putting a k in for kx does stretch the graph as long as k is smaller than 1, right? Because you're making it go up and down that much more slowly. It compresses the graph if k is bigger than 1 because you're making the graph go up and down that much more quickly.